In today's lecture of e-commerce, we will study about the technology and legal issues in e-commerce. So we will cover the topics availability of telecom infrastructure, interoperability, bandwidth issues and technical standards, and the expansion of internet, that is 128-bit IP addressing issues. So three topics we will cover in today's lecture. Technological issues, telecom infrastructure. Here the objective is to design, develop and maintenance of e-commerce business venture. This is the main objective of e-commerce infrastructure or telecom infrastructure. So what we do, build an open scalable infrastructure, then develop the right value-added services, then use an effective sustainability model. So first objective is what we are building, an open, distributed, and safe infrastructure which is scalable and thus has provisions for future needs. Second objective, how we can use using internet-based technologies to demonstrate the value creation for the users and facilitate the delivery. Third objective is who will pay repeatedly, define the right business model to sustain in the future in tandem with the IT infrastructure. So these are the generally five objectives of the telecom infrastructure, that what we are building, how we can use and who will pay repeatedly. Who will pay for what? For your first and second objective. The customer will pay, but how? So this is what about the telecom infrastructure. So technological issues in infrastructure are e-commerce infrastructure identifies the functionalities of the hardware and software components, specifies the corresponding service level requirements, and describes the management and operations of the whole system. It may comprise briefly of the following components at a very abstract level. Software components use content management systems, web analytics, text analytics, application programming interface, database server, middlewares, etc. Object oriented, then transaction processing communications like HTTPS messaging, database example ODBC, the application middleware CGI. So these are the general software components which are used for the e-commerce infrastructure. The second is hardware components which are used are servers, proxy servers, load balancing systems, firewalls, encryption devices, and interactive voice response units, etc. These two types of infrastructure we need to develop for the e-commerce infrastructure. E-commerce infrastructure includes software components and hardware components, whereas software modules are content management systems, API, database management systems, and middleware, analytics, web analytics, text analytics, big data, then standards, object-oriented, communication protocols, database, and application-specific CGI. So these are the software components which are used for software modules. Then for analytics, we need this and we need to follow such standards in softwares. In hardware, we need servers, proxy servers, and load balancing system. And in securities, we need firewalls, encryption devices, and interactive voice response units. IVR. Technological issues, interoperability. The growth of electronic commerce depends critically on one issue, that is interoperability between different systems. What is that interoperability? The technical features of a group of interconnected systems which ensures end-to-end provision of a given service in a consistent and predictable way. Interoperability links systems together. It enables banks to link together their cash point networks, extending the number of points at which service can be provided in a consistent and predictable fashion, even though ownership remains split between the individual banks. This is called the interoperability. So technical approaches to interoperability in e-commerce is technical interoperability is closely linked to standardization, often considered as a prerequisite for a global and open e-commerce marketplace. It has been variously interpreted, such as using standards or standards-based protocols, adopting a common technical framework at a basic level, providing a core set of services or service feature sets, implementing complementary products, or a basic suite of software tools, defining a stable system architecture that has the support of the largest possible number of entities. Then the next topic is the expansion of internet, that is 128-bit IP addressing. Internet Protocol or IP version 6 is the next generation IP, and it is the successor of IP version 4, which is widely used nowadays. Currently also, maximum times IP version 4 is in use. Very few organizations are using IP version 6. The development of IP version 6 started in 1991 and was completed in 1997 by the Internet Engineering Task Force and was officially used in 2004 when ICANN added IP version 6 addresses to its DNS server. An IP version 6 address uses 128 bits as opposed to 32 bits in IP version 4. IP version 6 addresses are written in using hexadecimal as opposed to dotted decimal in IP version 4. An IP version 6 address consists of 32 hexadecimal numbers. These numbers are grouped in fours, giving 8 groups or blocks. The groups are written within a column as a separator, group 1, group 2, etc. till group 8. So here is IP version 6 address example. So these are the we have split it into the 8 groups with the help of columns. Okay, double zero double zero shortened to zero. If there are double zero 4 times zero, then we can simply write it zero. And what is the meaning of all these things? We will understand in the next slide. Network and node address. IP version 4 and address is split into two components, a network component and a node component. This was done initially using address classes and later using subnet masking. So today also in computer networks we study about all these things, subnet masking and all. We are studying of IP version 4. In IP version 6, we do the same. The first step is to split the address into two parts. The address is split into two 64-bit segments. The top 64 bits is the network part and the lower 64 bits the node part. 128 bits, 64 bits belong to the network and the remaining 64 bits belong to the node part. The upper 64 bits are used for routing. These 64 bits are used for the routing. The lower 64 bits identify the address of the interface or node and is derived from the actual physical or MAC address using IEEE's extended unique identifier format. Upper 64 bits are split into two blocks of 48 and 16 bits respectively. The lower 16 bits are used for subnets on an internal networks and are controlled by network administrator. The upper 48 bits are used for the global network addresses and are for routing over the internet. So in the first 64 bits, the first 48 bits are used for the global network addresses and the remaining 16 bits are used for the subnets or for the routing person within a organization, internal network. So these are the references of the current topic. And in the next topic, we will study about the legal issues, which includes Uniform Commercial Code for E-commerce, Model Law on Electronic Commerce by United Nations Commission on International Trade Law, IT Act 2000 by Government of India. Well then, thank you